Alright folks, here's my video going over the question set that I gave you. It is on work machines and energy. So the equations you're going to need are, as always, all up here. Work is equal to force times distance. You are going to need, for one of the questions, the force of friction equation. And of course, just remembering that the force of gravity, the weight of an object, the force of gravity is equal to the mass of that object multiplied by the acceleration due to gravity. And you're always going to use 10 because frankly I'm too lazy to use 9.8. So the first question is easy enough. Car travels a distance of 200 meters as the engine applies a constant force of 12,000 newtons on the car. How much work does the engine do on the car? Plug and chug. Work is equal to force times distance. It can't be easier than that. Just make sure you give me the right unit at the end. Next one, fellas chopping firewood with an axe. Excuse me, applies a downward force on the axe of 300 newtons, which drives a wedge of the axe 0.15 meters into the wood. How much work does he do with the axe? I think that this is exactly the same. Honestly, I don't think there's anything different here. Work is equal to force times distance. You just got to identify that the force is 300 newtons. The distance is 0.15 meters. And I think that's pretty much it. In fact, I can't believe I've given you two such simple questions. But that's okay. Alright, question 3. Hugo delivers refrigerators for a living. Has to lift a 55 kilogram refrigerator into the back of his truck. The back of the truck is 0.8 meters off the ground. What is the weight of the refrigerator? Alright, this is where we're going to use this equation. The weight is mass times gravity, right? So, what is the weight? The weight is the force of gravity is mass times gravity. So it's going to be 55 times 10 meters per second squared. And that will give you an answer there. Remember the force, so it's going to be in newtons. That's going to be the unit. That should be a cycle. How much work is required to lift the refrigerator 0.8 meters? Okay, so here's the deal. Work is equal to force times the distance. You just figured out what the force was here, right? So you're going to plug that in there, and then the distance is going to be 0.8 meters. You're going to plug that in there, and that will give you an answer there. Then it says he uses a 4-meter long ramp to lift the refrigerator to the same height. What force would be needed to apply? Would he need to apply to move the refrigerator up the ramp? Neglecting any friction, which is actually a very important point, because if there was friction, you've got to do a whole number of calculations, which we don't want to do. So the key thing here is to remember that you cannot cheat work. Whatever work he did lifting it straight up here is going to do the same amount of work lifting it up there, right? Same amount of work. The only difference is it's over a longer distance, so it's a smaller force. So we are going to go back to work is equal to force times distance. Whatever you got your answer here, whatever that work is, it's the same work right over here. The force you don't know, but the distance is 4 meters long, so you can plug that into there, and then you're just going to rearrange that, and I think we did this in class. It's just going to be force is equal to work over distance, and then you're done. So that's that. Alright, next one is Stanley is lifting a 240 kilogram. I'm going to change that in the worksheet before I print it out tomorrow. 240 kilogram engine from a car using a chain block. Every time Stanley pulls 1 meter of chain, the engine lifts 0.025 meters. Calculate how much force Stanley applies to lift the engine. Alright, so first question is, what's the weight of the engine? Alright, same old thing. Remember, the weight of anything is equal to the force of gravity acting on it, which is equal to mass times gravity, right? So 240 times 10, you got your answer right there. Part B, how much work needs to be done to lift the engine? Same thing. Work is equal to force times distance. Again, whatever this force is, whatever that number is, which should be in newtons, right, because it's a force, has to be plugged in here, and then you're just going to plug in the 0.025 there. How much force does Stanley have to apply? Okay, so there's actually kind of a couple of steps here, because whatever work it takes to lift the engine that little bit, it takes the same amount of work for Stanley to pull this chain towards him, right? The only difference is this is a big force over a very small distance. This is a tiny force over a big distance, right? So what we're going to do is we're going to start off with work is equal to force times distance. We are going to remember that whatever the work is that it takes to lift the engine, Stanley has to do that same amount of work. So we're going to plug that in there. But what we're going to do is we're going to remember the fact that Stanley is pulling a meter's worth of chain every time. That's a distance, right? That's the distance that his applying his force over. So then you're going to plug those into there. That will give you the force. So I think ultimately it's going to be the same thing. Force is equal to work over distance. Alrighty, question 5 is probably the hardest one. Softball player slides 3 meters into base. Coefficient of static friction between the player and the base is 0.3. How much work was lost by friction in the slide? Alright, great question. Alright, so first draw a free body diagram. Alright, what we got? We got gravity acting down, right? Force of gravity, which is the weight, which again is equal to mass times gravity. I've got the normal force acting up. Normal force is mass times gravity. And I've got friction. Force of friction right there. Calculate the normal force. Well, again, the normal force is going to equal, or let me put it here, force normal is going to equal the force of gravity, which is going to equal mg. So it's just going to be, the person has a mass of 64 kilograms, plug that in there, times 10, so I guess 640, isn't it? Calculate the force of friction. Alright, this is where I said you need to remember this little equation right here, where we say the force of friction is equal to mu times the normal force. Well, guess what? We know that the mu is 0.3, right? So I can plug that into there, and I know the normal force because I just calculated it right in the question above, right there. So I plug that in, and that'll give me the force of friction, and I have no idea what that is because it's late and I can't brain right now. And then it says calculate the work done by friction. So here's the thing, the force of friction did the work slowing this person down. They slid in this direction. I'll do it as a dotted line. In that direction. So work is equal to force times distance. The force is the force of friction. The distance is right here, is 3 meters times the distance. And that is going to give you your answer. However, here's what you got to think about, and again, don't worry if you don't get this straight away. We will go over it more on Thursday, Friday. Energy is leaving the system. The person had energy because they were moving, right? The force of friction is actually moving to the left. The force of friction vector is moving to the left, whereas the person is moving to the right. So these are technically 180 degrees from each other, which means it's going to be negative work. Work is coming out of the system. Yeah. I know that's kind of a weird thing, but the answer is going to be negative, and I don't know what the number is, but you can put that in. Just remember the unit is joules. Okay, that's it. That's all I got. I hope this helps. I hope everyone's able to get this worksheet done tomorrow. If you get it done, obviously you can chill out. Other than that, I'm going to sign out. Any burning questions, feel free to email me because I'll be at home. All right, take it easy. Have a good day, and Wyatt out.